Okay. Hello. All right, guys. So we're basically just going to be going over the latest sheet that I did assign. If you have any other questions about the previous sheet and the unit circle, please don't hesitate to ask me, guys, because I know I'm only doing this twice a week now. I'm doing that purposely because I want you guys to, come twice a week to actually answer, ask the questions that you need. All right. I feel that before, when I was doing it daily, not enough kids came, and so they took the classes for granted. Now, if I do it less times, they won't take it for granted. All right. So we're going to go over this. This is unit circle, week 31, sheet 1. This is, again, can be found in eMath instruction. We're looking at the definition of the sine and cosine functions, Common Core Algebra 2 homework. Okay, so it says, which of the following is the value of sine 60? I'm going to use the trusty unit circle, reference circle that I did give you guys in the worksheet. I'll try to leave a link to it below too. So let's look at this right now. So we're looking for the sine of 60, right? So we have the sine of 60. Keep in mind that the sine represents the y values, the y coordinate values. So if we're looking at 60 degrees right here, if we're looking at the unit circle, we're looking at 60 degrees, we're looking at the y values. So it's going to be radical 3 over 2. Radical 3 over 2 is our answer. Any questions on that, guys? The first one. Everyone see where I'm getting it? Everyone see where I'm getting it, right? Okay. So now let's look at the second question. Written in exact form, the cosine of 135 degrees is going to be what? Keep in mind that the cosine deals with the x value. So cosine of 135 degrees would be what? Which one, guys? What answer do we think it's going to be? Well, okay. It's going to be negative radical 2 over 2. Right, and we see that? Again, this is for my reference sheet. The next question says, which of the following is not equal to the sine of 270 degrees? So at the sine of 270 degrees, right? Again, sine represents our y value. So at 270 degrees, our y value is going to be negative 1. So if we look at the cosine of 180 degrees, which is the x value, that's negative 1. So that's out. Which one is not equal? Now, if we look at the negative sine of 90 degrees, where the sine of 90 degrees is going to give me 1, and if you have a negative in front of that, it's going to be negative 1. So 3 is out. So that's a good 2. We're looking at 0 degrees, right? The cosine of 0 degrees, which is the x value. So that's going to be negative 1, which again is negative 1. And the last one says the sine of 360 degrees. Sine of 360 degrees is going to be the y value of 360 degrees, which is 0. So our answer is going to be 4. I'm going to understand that. Let me just double check to see if I did put a notification to let everybody know that I press enter. Yeah, okay, I did. Okay. Okay. Sorry about that. Okay, in any regards, okay. So now, 4 says the terminal ray of an angle drawn in standard position passes through the point 0.28, comma, negative 0.96, which lies on the unit circle. Which of the following represent the sine of this angle? Keep in mind what the sine is. The sine represents the y value. So the answer can only be numero uno, 1, negative 0.96. Everyone got that? Let's look at question 5. The point A, which is negative 5, 12, lies on the circle whose equation is x squared plus y squared equaling 169. Which of the following would represent the cosine of an angle drawn in standard position whose terminal ray passes through A? Again, the standard formula for any circle is x squared plus y squared equaling r squared. In this case, the r squared value is going to be 169. Leaving, so we have r squared equals 169. So leaving r equaling the square root of 169, which we all know is 13. They say point A is negative 5 and 12, right? So which of the following would represent the cosine of an angle drawn in standard position whose ray passes through this? Okay, so I'm looking over this right here. Okay, this thing may cross out for me, so I'm just going to do it this way, okay? So it's negative 5, which is the x, right? 1, 2, 3, 4, 5. And 12. Well, this is oh, let me redraw that for you guys. We know that r is 13, okay? Let me redraw that. So, it's probably gonna cross it out there. Sucks. This thing sucks bad. All right, so we're looking at negative 5, 1, 2, 3, 4, 5, negative 5, 12. Negative 5, 12, which is about right here. It's about right here. Whatever, it's about right here. Call it negative 5, 12. Negative 5, 12, right? So that means it goes 5 units on the x-axis and 12 units up. So I'm left with a triangle like this. This is 13 in the radius, 12, 5, 12, 13. So they want to know the cosine. Remember from SOHCAHTOA, cosine is adjacent over the hypotenuse. So that's going to be, since this is a negative right here, remember this is a negative 5. So that's going to be negative 5 over 13. That's my hypotenuse. That's hypotenuse. Everyone get that? Negative 5 over 13. Let's see what's going on. I do believe that I gave you two sides of this, and I also gave you the unit circle chart as reference. So I'm going to take a snippet of 6 through 11 now. Give me a second, guys, all right? Clear everything here. Let's go through here. Was it here or was it here? I put it here. Okay, it was here. Okay. Ask me any questions, guys, you may have. So I'm going to get rid of this so that it blocks this. Yeah. Okay. And here. Okay. So we're looking at 6 through 11. I'm not sure if I'll do all, but I'll stop at around 10:55. Ask any questions you may have. Take it from there. So, the first one says, which of the following values cannot, again, be the sine of an angle? Hint, think about the range of the y values on the unit circle. Okay, so we're looking at the y values for the unit circle right here. And I hope you have your unit circle in front of you guys. We want to know which one cannot be the range. Think about the range of the y value. Okay. So we're looking at 11, 13. So with this one, when we're looking at this, we're trying to see which one is the most oddly placed, and which one can't be reduced. So we're looking at the y value range. We're looking at the so if I had to just take a about being able to explain this perfectly, guys, I would say the answer would be 4. Just give me I want to be able to explain it. I don't want to explain it. Trying to think. It's the change in the y with change in x, which is essentially what this is, which will represent the angle. Well, let me get back to you on question 6, guys, all right? The answer for 1 and 2, Jeff. Do you understand why? It was 3 and 2. Okay, so for 7 it says, for an angle drawn in standard position, it is known that its cosine is negative and its sine is positive. So in other words, the x is negative and the y is positive. The terminal ray of this angle must terminate which quadrant? Anybody? That's the easy one. Anybody? It's got to be in quadrant what? Keep in mind, when you're looking at the quadrant in a unit circle, it runs counterclockwise. So quadrant 1 is the... So let's see right here. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. All right, so it's telling me that the cosine is negative, right? So x is negative, and the y is positive. So that's only one quadrant right here. One. Quadrant 2. Because we have to run counterclockwise, right? This is probably going to erase all this right here, but yeah, right. 8 says, if both the sine and cosine of an angle are less than 0, so that they're negative, right? Then when drawn in standard position, in which quadrant would the terminal ray fall? So they're both negative. There's only one quadrant in which they're both negative. That's going to be quadrant 3. Let's see that already. Which of the following has a cosine that is different from sine 30 degrees? So let's look at sine 30 degrees, right? So we'll go to 30 degrees and we look at the sine. The sine, again, is going to be the y value. Now we're looking for a cosine. Okay, we're going to put a cosine 60 degrees. Let's look at cosine 60 degrees. Cosine 60 degrees, which is going to be the x value, that's also 1/2. So the first one is out. Then we look at cosine negative 60 degrees, right? Cosine negative 60 degrees is going to be, it's going to be in the opposite direction. So we're looking at 60 degrees before, so we're looking at 300. We're looking at 300. We're looking at 300. And if you look at a cosine negative 60 degrees, that's going to be 1/2 again. So that one works out too. That's also equal to the sine of 30 degrees. Everyone see that? Because negative, if positive goes counterclockwise, then negative goes clockwise. So negative 60 degrees, I'm going clockwise down from 360 to 300. Then we look at negative 300 degrees, right? So negative 300 degrees is going to give me a positive, what, 60? So it's going to be a positive 60. So 2 works out. So 1, 2, and 3 actually work out. The last one says the cosine of 120. So I'm looking at 120, angle 120, and look, the cosine is the x value. That's negative 1/2. That's not positive 1/2. So we're looking at an answer of 4. When drawn in standard position, an angle alpha has a terminal ray that lies in the second quadrant and whose sine is equal to 9/41. What is the cosine of alpha in rational form? Keep in mind what this is. The sine. The sine is. Let me erase a lot of stuff right here. We have. I'm drawing it right here. It's telling me the sine is ultimately 9/41, so I know my hypotenuse is 41, and it's opposite of this right here, so it's 9. So I want to know, this is probably the last problem I'm doing, and I'll leave number 11 for you guys to do. We need to know what this is right here. If we want to be able to find a cosine, it's going to be something over 9. No, sorry, it's going to be something over 41, right? We don't know what this part is right here. So in order for us to find this, we can use what? Pythagorean theorem. All right, so we have 41. Erase a lot of stuff right here. We have 9 squared plus, call it b squared equals 41 squared. So that's 81 plus b squared equals 41 squared, which is going to be what? 41 squared is going to be what? Let me see. 41 squared. 1681. So now I'm gonna have this is 41. So now I have 81 plus b squared equals 1681. So you have b squared equaling 1681 minus 81. B squared equals 1600. Right, it just leaves us with 40. So you're gonna have 40 over 41. So b equals 40. So your answer is gonna be cosine. Cosine 40. Sorry, cosine alpha equal to 40 over 41. Everyone see that? Any questions, guys? That's for now. Again, I'll be back on Thursday too to do more on this topic. All right, since we can spend a little more time on this, since extra added Regent's pressure. All right, but if you have no questions here, guys, where'd you get B? Oh, B. Okay, so I used Pythagorean Theorem, Jeff. So it's a squared plus b squared is equal to c squared. Right? We knew that. It said that the sine is equal to 9 over 41. Remember SOHCAHTOA? So is opposite over hypotenuse. So this is my reference angle right here. If this is going to be my terminal side. So what's opposite of this is 9. And this is the hypotenuse. Destroyed it. That's going to be my hypotenuse. So 41 is my hypotenuse. And so now I know how to set up my right triangle. Right, my right triangle was essentially just 9, 41, and that's B. All right. Any other questions? Any other questions on this, guys? You got that, Jeff? All right. So if you have no other questions, guys, I'm going to end this live stream. Continue the sheet, guys, and also please continue the work that I did assign on study.com. All right? I may assign another assignment on study.com. Just keep abreast of the situation and constantly check the live stream. All right? Till then, guys, I'm going to end this live stream. And I will speak to you guys on Thursday. See ya.